Lesson 61, simplifying radical expressions. Radicals are simply square roots, or perhaps higher roots. We could have cube roots or fourth roots or fifth roots. We might even write, say, the cube root of 8 would be the number that, when multiplied times itself 3 times, would give us 8. Well, the cube root of 8 would be 2. The fourth root of 16 would also be 2, because 2 times 2 times 2 times 2 is in fact 16. So radical expressions are expressions that have radical signs or square roots or other roots in them. Okay, so here are some properties of radicals, and this is called the product property of radicals. If I have the square root of a times the square root of b, that's equal to the square root of a times b. You could put it all under one radical. Well, if I can go that direction, I can certainly go back the other direction. The square root of ab is equal to the square root of a times the square root of b. So here's a radical that perhaps we can use this product property of radicals to simplify. We could write this radical, square root of 225, as the square root of 25 times 9, and we could separate that into two radicals, the square root of 25 times the square root of 9, and we know the square root of 25 is in fact 5, and the square root of 9 is 3, and then 5 times 3 is 15. So the square root of 225 is 15. Could we use that same concept to simplify this radical? Well, let's try to think of factors of 180 that have perfect square roots. The numbers we should check are numbers that have perfect square roots: 4, 9, 16, 25, 36. So let's see. Well, I can see right away that 9 will go into 180 evenly. So 9 goes into 180. Square root of 20 times the square root of 9, because 9 times 20 is in fact 180. But 20 also has a factor that has a perfect square root. So we could write this as the square root of 5 times the square root of 4 times the square root of 9. Well, we know the square root of 4 is 2. Square root of 9 we know is 3. And 2 times 3 is 6. So we could simplify this radical, the square root of 180, as 6 times the square root of 5. Well, what about the square root of 10,000? Wow, what a big number. Well, we could simplify. We could write this as the square root of, what, 100 times the square root of 100 again. Well, the square root of 100 is 10. Square root of 100 is 10, so 10 times 10 is 100. We could look a little closer here. We can see that how many zeros do we have here in this number? Well, we have 4 zeros. How many zeros does our answer have? It has 2. So if we'll divide the 4 zeros by the square root, the number 2 here, we would get 2 zeros, so our answer would be 100. And this number right here is called the index. If there's no number there, it's understood to be 2. If this had been the cube root, like we had a while ago, the cube root of 8, okay, that's still called the index, and this indicates that that's the cube root of 8 rather than the square root of 8. Okay, so here's an expression that has some variables in it. So we could write this as the square root of 81 times the square root of x to the 4th times the square root of y cubed. Well, we know the square root of 81 is 9. We know that x squared times x squared is x to the 4th. But what about y cubed? Let's write it a little different. Let's write it as the square root of y squared times the square root of y. And now we know the square root of y squared is y. So how would this radical simplify? It would be 9 x squared y times the square root of y. So that would be our simplified answer to this radical. Okay, what about this one? Well, let's see. Let's think of numbers that have perfect square roots. Let's see, 4. 4 won't go into that. Will 9 go into that? How do we tell if 9 will go into 162? Well, we add the digits together, and does 9 go into that? Well, 2 plus 6 is 8, plus 1 is 9. But 9 goes into 9, so 9 is a factor. So we could write this as the square root of 9. 9 times what is 162? Well, I can't do that in my head, so I'll come back to old-fashioned arithmetic here. 9 goes into 16 one time, and that would be 9, so that would be 72, 18 times. So square root of 18, well, square root of 18 has a factor. We could pull out another square root of 9. So let's just erase the square root of 18 here. Oops, let's make our eraser a little bigger. And we could write this as the square root of 9 times the square root of 2, because 2 times 9 is 18, and then 18 times 9 was 162. Well, we know the square root of 9 is 3. Square root of 9 is 3. But now let's do our square root, our variables here. So we got the square root of r to the 4th, and we know that is r squared. And s to the 8th, we can write that as the square root of s to the 8th, and the square root of s to the 8th is s to the 4th, because s to the 4th times s to the 4th, we add exponents. 4 plus 4 would be 8. So our answer here would be 3 times 3 is 9, square root of 2, r squared, s to the 4th. Now a little trick here on taking the roots of variables that I'll show you. You notice that this exponent 4, what was our root here? 2. Well, will 2 divide into 4? Yes, it will. 2 divides into 4 2 times. Will 2 divide into 8? 8 divided by 2 is, in fact, 4. Let's go back and look at this one. We had a 2 here, understood. 2 divides into 4 2 times, and our answer was x squared. But 2 divides into 3 one time. Well, here's our 1 here, but we had 1 remainder, so we have to leave 1 under the radical. Okay, so lesson 61 homework will be 1 and 2, 4 through 8, 10 through 14, and number 30. And after watching the video, email the answers to numbers 1 and 2 to me. In addition, you should work 6 to 8 additional homework problems before class in order that you be able to finish and check the assignment during our next class meeting.